Morning, everyone. Our time is exactly 11:15. Let me just welcome you all on this session. So before we start with our lecture, let me just give you the following announcement. They're very important. Actually, it's a reminder because you are aware that next week on Wednesday on the 9th, you're going to write your first assessment. And that is your first quiz. Then the following week, you're going to write the first test on the 16th. So maybe you'll be asking yourself, what is the scope of the test or the quiz? I think it's everything that we have done so far. But to be specific, let me just tell you that we are going to focus on chapter 1, chapter 2, and chapter 3. Only 3 chapters. This scope covers is going to be for the quiz and also for test number 1. Are we together? If you have any question, you may ask. You're going to write your first quiz next week on the 9th, and it's going to be online, but test number 1 is going to be face-to-face, as I have already indicated.
Sir, is the quiz multiple choice or scanning?
No, it's not a multiple choice. You're going to scan. The quiz is not a multiple choice. You're going to scan. Any question? None. So today, maybe if you have any question, clarity, you want to be clarified on, we are going to have a tutorial. So at least 1 hour for you to ask questions, then I'll be there to assist you in that regard. So now, in the absence of any questions, can I proceed? Okay.
Yes, sir, you can proceed.
Okay, thank you very much. Let's start with our lecture. Okay, let's start. You will recall that we have already done the moving average processes and the autoregressive process. Under moving average process, we did moving average of order 1, order 2, and then later we generalized. Okay. May you please mute your mic? Okay, thank you very much. So now for autoregressive process, we did the same. There is somebody who didn't mute the mic and is disturbing.
Becky, mute your mic.
Please mute your mic. So we did autoregressive of order 1 and of order 2. So now today we just want to combine the two processes. I mean, moving average and autoregressive processes to become one process, okay? So we are going to combine them together. Remember, for moving average process, if you want to generalize it, it's going to be a moving average of order Q. That is how we generalize the moving average. Moving average of order Q. And then is the process until order Q. So now for autoregressive process, we're going to generalize until order P. So then when you combine the two, you're going to get a new process called ARMA PQ process. Are we together? It's the combination of the two processes, moving average and autoregressive. moving average of order Q and autoregressive of order P. When you combine them together, we get a mixture of the two models, become one, and then the new process now becomes ARMA PQ. Okay, just write it down so that you can understand it. That is lecture number 11. So the process that we're talking about, like I said, is the combination of autoregressive and moving average to becomes ARMA. Becomes ARMA PQ. Okay, process. So we're saying it's ARMA process because it's the combination of the two models. In other words, we have got the autoregressive and the moving average. So autoregressive is of order P and the moving average is of order Q. Okay. So now, if you still recall, in a moving average process, we always say that the moving average is always stationary, but it's not always always invertible. So if you have been given a process, you can check for invertibility in the moving average. So the same applies to the autoregressive process. It's always invertible, but it's not always stationary. So if you have been given a process of autoregressive process, you have to check for stationarity or causality. So, but in this regard, we have got now one process. In other words, we combine the two processes to become one. The other, you have to check invertible. The other one, you have to check the stationarity. So what about if you combine them together? How are you going to identify that? How are you going to check whether this process is stationary or this process is invertible? So you are going to check the invertibility under the moving average process. On the same process, you're still going to check the stationarity under autoregressive process. So how do you define ARMA PQ, which is the autoregressive moving average process of order P and Q? So the ARMA PQ is defined by this. Let me just use this one. It's defined by xt, okay, which is equal to phi1 xt minus 1 plus phi2 xt minus 2. Because we are generalizing it, it's going to be plus phi p xt minus p. So this one now is autoregressive process. So on the same process, you can add the moving average process. So how do you combine them together? So you're going to have what? Plus zt, sorry. We're going to have plus zt, okay, then plus theta 1 zt minus 1, okay, plus theta 2 zt minus 2 plus, because even in this case you have to generalize the moving average, so it's going to be up to theta q zt minus q. Are we together? So now this process is called ARMA PQ. Why? Because we've got the autoregressive of order P and the moving average of order Q. So that's why we're having such structure. So now we can just separate them together now. So the autoregressive process, let's write them on the left, and the moving average process on the right. Try to separate them by equal sign. So you're going to get what? So now you take phi 1 xt minus 1 plus phi 2 xt plus phi 2 xt minus 2 up to phi p xt minus p to the left. Okay. So when you take it to the left, it changes sign, as you know. Plus that xt minus phi 1 xt minus 1 minus phi 2 xt minus 2 minus up to phi p xt minus p, which is equivalent to what? So now we take everything that contains x to the left. Then we are left with what? With zt plus theta 1 zt minus 1 plus theta 2 zt minus 2 plus theta q zt minus q. Are we together? I think it makes sense. Now, after doing this, now we take auto on the left, moving average on the right. Then let's write them in backshift operator. Okay. Whatever on the left, you are going to write it on backshift operator, and the process on the right, you just write it in backshift operator also. So what do you get? In backshift operator, you're going to get what? 1 minus phi 1, what? B, isn't it? Minus phi 2 b squared. Okay? Minus until what? Phi p b to the power p, isn't it? Because it's in backsheet operator, you close the brackets and you multiply by what? By xt. That's on the left. So on the right, you do the same thing. You're going to have 1 plus theta 1b plus theta 2b squared plus up to theta q b to the power q. Then you do the same, you close, then you multiply by zt. So now we wrote our auto regressive process in backshift operator. The same applies to the moving average. Okay. So both of them are in backshift operator.
Sir,
Are we still together?
sir,
Any question? Yes.
when we write this backshift operator on the right hand side, are we still going to use the same coefficient b?
Yes, you should use the same b, because it's a b stand for the backshift operator or backward shift operator. So that's why we use the same b on the right and on the left. The only different is the parameters. The parameters on the autoregressive process is different from the one on the moving average process. As you see, on the autoregressive we use phi, but on the moving average we use thetas. Any question? Okay. So now this is our backshift operator. So now the statement or the process on the left can also be written as phi b xt, and the process on the right can also be written as theta b zt. So can we go to that step, the next step, please? Can I go to the next page?
Yes.
Okay, thank you. So what I'm saying is this implies that, okay, on the left You have got 5b xt, which is on the right. It's theta q.
Sir, can you go back a little bit? Can you go back?
Okay, zt. Yes, I'm back. So you have a question, or you just want to finish writing?
No, I want to finish coping,
Oh,
of
okay.
which
Okay.
I'm done.
You're done. Thank you very much. So now I was saying that now the autoregressive process of order P is on the left. It can be written as phi p b xt, and the moving average process can be written as theta q b zt. And again, it's still in backshift operator. Yes.
How did you arrive to that step?
Before.
No, the one you just wrote now. How did you arrive?
Yes.
How did you arrive to this step?
How? Okay, if you can go back a bit, if you check the process on the left, is the autoregressive process in backshift operator. And it's denoted by phi's. Because we are generalizing autoregressive, we are generalizing to be of order P. So that is why here in the next step, that is why here we're having phi P. This phi P, this one, just indicate that now we are dealing with the autoregressive of order P. But in what? In backshift operator. That is why we're having what? This B here. And then xt is the same as the one that you wrote before. Xt is the same as this one. Okay. So we said we generalize everything within the brackets. S phi what? Because autoregressive process S phi P. Okay. Then B for the backshift operator, then xt. The same applies on the right hand side for the moving average. We have everything within the brackets. We are dealing with the thetas. Theta of order what? Order Q, because we were generalizing it. Okay. So that is why we're having theta Q and B for the backshift operator and then ZT. So that means this statement is the same as the previous statement. And the previous statement is the same as this statement that we wrote it here. So again, this is what? This is armor PQ. But in what? In backshift operator. So there is no different on that regard. Any question? Okay, now let's say for armor PQ, the armor PQ there, that process that we wrote there, if we let P to be equal to 0, okay, and Q to be equal to 1, okay. So now the armor PQ, the armor PQ now will becomes what? Armor 01. Are we together? If you let P to be equal to 0, the order of autoregressive to be equal to 0, and the order of a moving average to be equal to 1, we are going to have armor 01. Or if you don't want to write armor 01, you can just write MA1. Okay. If you don't want to write ARMA 01, it's MA1. What does that mean? It means that in the autoregressive, we don't have an autoregressive process, but we have got a moving average of order 1. So that is why we are having moving average of order 1 there. The same applies if our P is equal to 1 and our Q is equal to 0. So ARMA PQ now becomes ARMA 10. Okay? Or what? AR1. So what does that mean? It means that if you have got an autoregressive of order 1, but you don't have a moving average, so the whole process now becomes autoregressive of order 1. So that is what we are having there. So the same applies in another scenario. If both P and Q are equal to 1, so ARMA PQ now becomes what? ARMA 11. So in other words, we have got a process which is an autoregressive of order 1. Then you combine with the autoregressive with a moving average of order 1. At the end of the day, you have the mixture model called ARMA 11. Okay. In other words, the autoregressive of order 1, a moving average of order 1. It's ARMA 11. So how do you write ARMA 11 now? Okay. In terms of the process, ARMA 11 now can also be written as what? XT is equal to phi 1 xt minus 1 plus zt plus theta 1 zt minus 1. And remember, zt is a white noise as usual. Okay. See now, that ARMA 11 process, it can be written as what? Xt equal to phi 1 xt minus 1 plus zt plus theta 1 zt minus 1. That is autoregressive moving average of order 1, 1. Any question before we proceed? None. Okay, now it's fine. Okay. Any question? No. Okay.
So, sir,
now, yes.
is it possible to have P and Q both 0?
If you have P and Q both 0, so you don't have a process at all. So it's not possible because you won't have a process. So we will be talking about what?
Oh, okay.
Together. Yeah.
Yes.
Okay. Now, this is our process. Remember, I told you that if you want to check invertibility, you have to consider the moving average. If you want to check the stationarity, you have to consider the autoregressive process. Okay. Now, in this regard, we just want to calculate the autocorrelation functions
Can you please repeat
using our saying for the process ARMA 11, the one that I wrote it there. If you want to check for stationary, whether the process is stationary, you have to check for autoregressive process. And if you want to check whether the process is invertible, you have to check for moving average process. So which one is the moving average? Which one is the autoregressive process in this regard? So this one that contains xt minus 1 is the autoregressive process of order 1. Okay. And this one, which is zt and zt minus 1, is a moving average of order 1. So that means if you want to check whether the process is invertible, this way you have to check. Okay. Okay. But if you want to check whether this process is stationary or casual, this is where you have to check. Are we together? So in other words, in this regard, you can check whether parameter or the absolute value of phi 1 for stationarity, you have to check whether the absolute value of phi 1 is it less than 1. If it's less than 1, therefore the process is what? Is stationary. On the other hand, you have to check the moving average, whether the absolute value of theta 1 is it less than 1. If it's less than 1, therefore it's invertible. So, but anyway, you will see when we do the real example. Okay. It's clear, isn't it? Okay. Now, let's proceed. So in this regard, because we are not dealing with the real numbers, we just assume that the process is stationary. What does that mean? In other words, the absolute value of phi 1 is less than 1. Then is then that you can calculate the autocorrelation functions. Otherwise, we won't calculate it. Okay, let's assume that the absolute value of phi 1 is less than 1. Then we calculate the autocorrelation function. But before you calculate the autocorrelation functions, you have to calculate the autocovariances. In other words, you have to find gamma 0, gamma 1, gamma 2, up to gamma k. So how do you do that? So we name that process to be equation number 1. Is then that you can just come up with those gamma 0, gamma 1, gamma, up to gamma k. So let's do it. The process is xt, which is equal to phi 1 xt minus 1 plus zt plus theta 1 zt minus 1. And in this regard, we just assume that zt is a white noise. Okay. And again, absolute value of phi 1 is less than 1. This condition for absolute value of theta 1 of phi 1 is less than 1 is very important, because it's the one that allows us to calculate the autocorrelation functions, because now the process is what? Is stationary. So let me say this process is equation number 1. Okay. Now, if you multiply equation number 1 by xt and then you take expectations, what are you going to get?
Sir,
You are going to get, yes.
what did you write there at the bottom?
Come again?
What did you write there at the bottom?
At the bottom. Oh, yes, I know my handwriting is not good. It's end. This one is end. The other one is absolute value of phi 1, which is less than 1. Then full stop. So now we name it to be equation number 1. So multiply equation number 1 by xt, then you take the expectation. What are you going to get? You're going to get the expected value of xt on the right, which is equivalent to what? To phi 1 expected value. Okay. Of what? Of xt minus 1 xt. Isn't that we are multiplied by xt, then we take the expectation, then plus the expected value of zt xt. Okay, plus the expected value oh, sorry, theta 1. This one is plus theta 1 expected value of what? Zt minus 1 and xt. Okay, this is what we're talking about. We are multiplying equation number 1 by xt, then later we take the expectation. So this is what we are going to get. Now, what is the expected value of xt and xt? You can tell me. Expected value of xt and xt is gamma 0.
It's
Gamma 0. Okay. Then if I want expected value of xt minus 1 xt is gamma 1
Gamma 1.
plus the expected value of zt and xt sigma squared z plus. So when we come to this regard, expected value of zt minus 1 and xt, actually it's supposed to give us 0 because there are two independent variables. Now, but we can take it as an unknown value, this one. We don't know it. Before we take it to assume to be 0. So let's take it as an unknown value. If it's unknown value, so we have to calculate somewhere. We have to find the expected value of zt minus 1 and xt. So how do you do that? You multiply, if you multiply by equation number 1 by zt minus 1, is then that you can get the value of this expectation. If you multiply equation number 1 by zt minus 1, then later you take expectation. Yes.
Where does this sigma come from?
Sigma squared z.
Mm.
Okay, I will explain to you. Zt minus 1 xt. This sigma squared z, this one, is because this one and this one, they are two variables. If you check the subscript, all of them is tt. So if it's tt, even though the variables there, they are different, so we take them as they are not independent. In other words, this variable is the same as this variable. If those two variables are the same, therefore their expected value is like the curve of zt and xt, which is the same as sigma squared z. I don't know whether you were there on Friday last week when we were doing this. We were doing something related to this. And I explained why did we get sigma squared z. I told them, those who were there, that if you have zt and xt here, so it's like they are the same variable. So we can find the expected value, which is sigma squared z. But if you have zt minus 1 on the first one, and here is xt. Oh, let me just use another example because this one we have it. If you have got zt minus 1 and xt minus 2, so you can see the subscript now they are different. Now the whole variable now changes, and we have got an independent variable. If you have got the independent variable, the expected value of the two independent variables is 0, or the covariance of the two independent variables is 0. So, but in this case, we just take it as they are not independent, they're the same because of this tt there. So that's why it takes us to what? To that condition of zt is a white noise, which is equal to sigma squared z. So that's why we're using sigma squared z there. I don't know whether you get my point or you get my explanation. Yes. Okay. So now let's deal with this unknown value here. This one, we don't know it. But I said, if you multiply equation number 1 by zt minus 1, then you take expectations, you are going to get this. you're going to get the expected value of, multiply equation number 1 by zt minus 1. Going to get zt minus 1, then xt on the left. Okay, then phi 1, you do the same, you multiply by zt minus 1, then you take expectation. In other words, you have got zt minus 1 and what? Xt minus 1. Take expectation, then plus expected value, then you have got zt minus 1 and what? And zt. Then set plus theta 1 expected value, what? Zt minus 1 and zt minus 1. Then close the brackets. So we just want to find the expected value of z minus 1 and xt. Okay, so this is equal to, so what is the expected value of zt minus 1 and xt minus 1? It's the same as this one up there, zt and
So
xt.
it won't be sigma squared z.
Yes, that's true. So it's phi 1 sigma squared z plus. So what about this one? Expected value of zt minus 1 and zt. It's going to be 0 because they are independent. Even though here they are the same, but here they're different. So it's 0. So what about expected value of zt minus 1 and zt minus 1?
Phi 1 sigma squared z.
Yes, theta 1 sigma squared z. So now we have got that unknown value that we were talking about. So expected value of z minus 1 xt is equal to phi 1 sigma squared z plus theta 1 sigma squared z. So we can substitute there, up there. So this implies that gamma 0 equal to phi 1 gamma 1 plus sigma squared z plus what? Theta 1 multiplied by what? Phi 1 sigma squared z plus theta 1 sigma squared z. So this is the gamma 0 now. So we can open the brackets, multiply through by theta 1 there. So we don't have a space, we have to go to the next page.
Sir,
Yes.
can you explain this one here, expected value of zt minus 1 and xt again?
I said, let me just use another color here. I said the expected value, this one, of zt minus 1 and xt, okay, it was supposed to be 0 because they are independent. But if you check equation number 1, we can multiply equation number 1 by zt minus 1, and then you take expectations. You're going to get something. In other words, you're not going to get 0. You're going to get something. So we need that something. So that is why here, now we multiply equation number 1 by xt minus 1, by zt minus 1, then you get this one on the left. Then you do the same, you multiply by z minus 1, you take expectations, then you get this one. You do the same for this one, you multiply by z minus 1, you get this one. Then you do the same for this one, you multiply by z minus 1, you get this one. So the question is, what is zt minus 1? So here, if we have got maybe something that we can multiply equation number 1 and get a certain value, we won't have a 0 here, but we don't have equation zt. So that is the problem. And we don't have equation zt minus 1. But here, we've got equation xt, which is this one. So we can multiply it by z minus 1 to get this, the whole expression here. So that is what we did here. Okay, and get it. So that means before you just say that this one and that one, they are independent, check whether indeed from the equation, can you multiply something by something and get something out of it? If it's possible, just go there and try. But if it doesn't, so you take it as 0. So that's what we did. Any question before proceed?
Oh, explain the last one, sir.
The last step, okay. The last step, we got it from the second last. We're saying, what is the expected value of zt minus 1 and zt minus 1? If you can check here, the subscript is 0, is t minus 1, and here is t minus 1. So because they are the same, so that means those variables are not independent. They are dependent. They are the same. So their expectations is taking us to what? To sigma squared z. So that's why we're having phi 1 sigma squared z there. Then plus this one, because they're different, so it's 0. So this one, because they're the same, here it's taking us to sigma squared z. That's why we're having this one. So after that, we come back to this. You can just call it equation number 2. Okay. Then you have to substitute what? This. What we got here. Here. This is what we did. So phi 1 gamma 1, which is this one, plus sigma squared z, which is this one, plus theta 1, which is this one. Then we substitute expected value of zt minus 1 and xt by this, what we got there. That's why we're using this within the brackets. I think it's clear.
Sir, sir.
Yes, you're welcome.
So when we find the expected value of unknown, so we have to always take to multiply it with the original equation and take the expected value.
Yes,
On
because
other
there is no
situations.
other way. Yes, there is no other way of finding it. You have to go there. Actually, you have to check whether, okay, if I can multiply equation number 1 by this, can I be able to get this value? Yes, it's possible. So that is why we did that. That is the only way of finding that unknown value there. Can we proceed?
Okay.
Okay, thanks. Let's go to the next page. So we're having gamma 0, sorry.
Sir, can you please go a little bit back?
Gamma 0, okay. Yes, here.
Okay, sir, thank you.
Okay. By 1 gamma 1, what? Plus sigma squared z plus sigma squared z plus theta 1, open brackets, by 1 sigma squared z theta 1 sigma squared z. Okay, it's like this, isn't it? The last step. Okay, which is equal to, now we can multiply through by theta 1 there. You're going to get by 1 gamma 1 plus sigma squared z plus phi 1 theta 1 sigma squared z plus theta 1 squared sigma squared z. So this is our gamma 0. Okay. This is our gamma 0. Now you have to find gamma 1. So you have to find gamma 1. Now we have gamma 0, you have to find gamma 1. So gamma 1, you multiply equation number 1 by xt minus 1, then you take expectation. So we are saying expected value of xt multiplied by xt minus 1. Then you take expectation. This on the left hand side. Then phi 1, if you still recall, expected value of xt minus 1, again xt minus 1, because you are multiplied by xt minus 1. Then you said plus expected value of zt xt minus 1. Okay, then you said plus theta 1 expected value of zt minus 1 xt minus 1. I think it's correct, isn't it? That's it. But you know that the expected value of xt minus 1 on the left is equal to what?
Gamma 1.
Gamma 1.
Gamma 1. Yes, that's true. So what about expected value of xt minus 1 xt minus 1? Gamma 0, isn't it? By
Yeah, it's
1
gamma 0.
plus expected value of zt xt minus 1, that is 0. Expected value of zt minus 1 xt minus 1, theta 1 what?
That one be sigma squared z.
Yeah, that's true. Sigma squared z. So gamma 1 is equal to that. So let me just call it equation. I don't know whether it's equation number 3. Yeah, because this one is equation 2.
Okay.
Oh?
Hello, Seth. I think I'm confused. Last time you said the expected value of zt minus 1 and zt minus 1, it is sigma squared z. But then now you say
Listen. You have to check this. Check the variables. Okay, let me just explain to you so that you can know it. Here we're talking about x and x. You see that one? Then subscript is t and t minus 1. Because it's x and x, so it has to take us to gamma something. So what types of a gamma is that one? So we check the subscript. Subscript, I told you that you have to say t minus t, then t minus 1, which is going to be equal to what? 1, isn't it? So that is why we're having gamma 1 there. It's x and x.
X.
Yes,
Sir,
but but if it's x, what is happening now? Can get an echo.
sir, so if the subscript are the same, like it's T and T is gamma 0.
If subscript are the same, no. I can get an echo here, please. Somebody can mute the mask. Okay, I'm saying if we're having x and x, okay, and then the subscript is t and t. You see that one? Because it's x and x there, it has to take us to gamma something. Okay. Gamma what? So it will be determined by the subscript there. So it's t minus t, which is equal to 0. So it's gamma 0. Because it's x and x. Now, if now it's x and z, okay, because it's x and z, it has to take us to sigma something or 0. Sigma something is going to take us to sigma something if the subscript is t and t. So therefore, you're going to have sigma squared z. Okay, in that regard. But if it's x and z, but here is t minus 1, here is t minus 2. You see, it's x and z. It's supposed to take us to sigma something, but the subscripts are different there. So because the subscripts are different, so we have got the independent. variables. Now it takes us to 0. You get that? But if it's xt minus 1 and zt minus 1, just to take you to sigma something. Sigma 1. So you check this because they're the same, so sigma squared z. Yes.
Since you are teaching many things at the same time, could you please give us our 10-minute break, sir? Because we have to.
You're tired.
Yeah, we are tired, sir, because of the formulas. Yeah, there are many formulas here.
So I do have another suggestion here. So what about if I can just consume your 10 minutes, then I'll give you on the last. In other words, instead of finishing at 10 to 1, finish at 22.
Yes, sir. That's a good idea, sir.
Yes, I think it will be better rather than taking a break. Let's continue, then we'll finish at 22.
Yes, let's continue, sir.
So, but anyway, you understand what
And even this thing
sir.
becomes a problem when we listen to the recording.
You know, the problem is that when you just continue, you are just writing anything.
Oh, you are no longer understanding.
Yeah, we are not longer understanding.
Yeah, if
Why can't
we want to understand these things.
yeah, and if you give us that 10 minutes, sir, we'll use it to look on what you wrote. If you give us that 10 minutes, we'll use it to look on what you wrote and get to understand.
No, it makes sense.
No,
Let me
and
just
when you
give
come
that
back, you
10
ask
minutes.
another question after another question. No, guys.
Yes.
Say continue.
No, in my case, I don't have any problem. If you need a break, I can give you. But if you want me to continue, I can continue.
Continue, sir.
I think it's better to continue. Isn't that you are going to check this?
We need a break.
Continue, sir.
We don't need
They
a break.
We need break,
They're
sir.
saying continue. They understand. So as we
Break
Continue,
it is.
sir.
we need a break.
No, stop.
Sir,
Continue, sir.
Okay, let me just give you a break. 10 minutes. You're
Continue.
going to... No, how can I continue others while they are... No problem.
We've been attending without a break.
Oh,
Sir.
we'll understand
Continue.
on
We
the
stop at half past.
Let's continue.
this one is a different
we'll understand on the recording.
tired. Continue, sir.
If it's a problem, we'll understand.
I mean a break.
Okay. Can I continue?
Yes, sir.
Sir,
Yes.
how can you continue while others want a break? Sir, if they want to continue, let them continue at their own pace. But for us, we want you to take a break. Sir.
Who is us?
There are 10 minutes forward.
Can't
Now,
you
even
read
if
on the
they
chat
give
box
you
or
10
on
minutes, if you don't understand, you don't understand.
So I think majority is saying continue. So please, can you
Continue, sir.
continue?
Even if you give us 10 minutes, if you don't understand,
Just
you don't
continue,
understand.
sir. Just continue. We'll start.
Okay, let
If
me
you
continue. But
consumed the
for
break
those
time,
who are having a problem, I can explain if you don't understand this. That is why I don't mind to go back and all those stuff. I just want you
It's
to
very
understand.
foolish to
Okay.
say should continue while others are away.
So
Let's just say it like this. Next time, like there won't be a break. Just today, let it be a break. But next time there won't be a break. Don't just say should continue.
what are you saying,
What
guys?
will
I agree.
Yeah? You're saying I have to stop. Next time we won't have a break.
No, let's continue, sir.
okay, okay, just continue, but don't forget the 10 minutes at the end of the session.
Yes.
We still need it.
Okay, so this is the question number 3. So I was trying to explain how do you get gamma 0, how do you get a sigma squared z. So is there anyone who's having a problem on that?
Yes,
You
can you please say?
huh?
Can you please go to the previous slide?
Okay. Yes, that's where I am.
I want to ask something on that theta 1 expected value of zt minus 1 and xt.
Oh yes, that's true. Ask.
Why didn't we just say that this one is 0? I don't actually get it.
Yes.
My brother.
Yes.
My brother. My brother.
Sure.
Hello.
Oh, sure.
The subscript t minus 1 and t minus 1 are the same. So it's sigma squared z because they are the same. But if they were different, it means they're going to be independent, makes it to be 0. So since they are the same, they are dependent, is sigma squared z.
He's
No,
not talking about that
I'm
one.
sorry, Faith, I'm not talking about that.
Which one?
Guys, we are dealing with two variables here. You must understand that there are two variables.
Sorry, one person at a time.
The white noise
Which,
and we have
which one are you talking about?
the x,
This
the x
one.
variable.
This one. Can you explain to him?
And we know the distribution of the white noise, but we don't know the distribution of the x. And so that's the information you have to put in your mind, that you know the
What are you guys
distribution of
talking
zt,
about?
but you don't know the distribution of x. And so,
So,
whenever you are
are you-
computing this expectation, you must be aware of the variables you are dealing with.
Okay, I assume that you were answering that guy who was.
Yeah,
You answered.
no.
I say I'm not answered.
What's going on here?
No. Okay, I said
You wanna know?
anytime if you want to check whether the two variables are independent or not. First thing you have to check, especially when you are multiplying, you are naming process to be equation something. So check whether if you can multiply that equation by one of the variables there, can we get something before you go to the independence? If you find that no, you can't do anything, so you can take it as 0 because they are independent. But in this regard, because you can apply this, you can multiply equation number 1 by xt, then you take expectation. By so doing, you are going to get the unknown variable, which is expected value of zt minus 1 xt. Then work on that, provided if it can allows you to do that, because in many cases it won't allow you to do that. So that is why you just go and take it as 0 in many cases.
Yeah. Say I now understand.
Okay. So now we were here. Okay.
Sorry, sir,
Question
go
number
back
3.
to the last slide.
Yeah.
When you're working on, you said the expected value of zt minus 1 and zt is 0.
Z minus 1, not Z minus 1 and xt. Which one?
zt. The one
Which
you
one
are
are you
dealing
referring
with
to?
right now.
The last part. The one that I was explaining.
Yeah, you said expected value of zt minus 1. Zt is 0.
No, I think you are referring to this one is Z minus 1 and xt. I don't know whether you are referring to that.
I mean the expected value of zt minus 1 and xt again, which is equals to
Yeah.
theta 1, expected value of zt minus 1 and xt. Oh, Taiwan, I mean you.
Yeah. Yes.
The,
So what are you saying?
etc. So you said expected value of zt minus 1 and zt is equals to 0. You see what I'm saying?
Not and zt and xt. When are you mixing things there? You're talking about
that last step.
Come again?
Okay, so can I ask something? The expectation of xt and xt is gamma 0, and the expectation of zt minus 1 and xt is also gamma 0.
You guys, now I don't get your question. Which statement, which line are you talking about here?
Okay, you see at the first you said the
And 5,
expectation
sir.
of xt and xt is gamma 0, right?
Yes.
And the second expectation is zt minus 1 and xt. Is it also gamma 0?
It can't be gamma 0.
Then what is it?
Which did I write to gamma 0? It can't be gamma 0, that one.
I see the last one is gamma 0 there.
This gamma 0
oh,
here
If you want to see,
coming from this one.
I understand, sir. I understand.
if you want to see it, change the process xt to xt minus 1, whereby you will be also changing the right hand side to be
Can
xt
we
minus
proceed?
2,
I think we're
zt
dwelling in
minus
one
1,
state for a long time.
and theta 1 zt minus 2, and therefore multiply by zt minus 1 and expect, you will be left with sigma squared z.
Yes, can we continue, please?
Yes,
Because
sir.
it's still a little. Yes, otherwise we won't finish this thing and our time is running. Okay, let me just erase this because I was trying to explain here. So you have equation number 3, equation number 2, and equation number 1. I think equation number 2 supposed to be this one because it's gamma 0, all of them. Let me just go back. I said equation number 2 is this one, but it's before we substitute it by expected value, isn't it? So let's take it to be maybe this one. Let's just take this one equation 3 and this one equation 4, because we're going to deal with this one. This one equation 4. Okay. So now you have got gamma 0 and gamma 1, equation 3 and 4. So you can substitute equation 4 from equation 3, isn't it? Then when you do that, you have gamma 0, which is equal to phi 1. So gamma 1 is the same as what? Phi 1, gamma 0 plus theta 1 sigma squared z. Okay. Then plus sigma squared z plus phi 1 theta 1 sigma squared z plus theta 1 squared sigma squared z, isn't it? Then you open the brackets, you're going to get phi 1 squared gamma 0 plus phi 1 theta 1 sigma squared z plus sigma squared z plus phi 1 theta 1 sigma squared z plus theta 1 squared sigma squared z, isn't it? So gamma 0 will be equal to, so you can add this one and this one together. Okay, so you're going to have gamma 0 phi 1 squared gamma 0 plus 2 phi 1 theta 1 sigma squared z, okay, plus sigma squared z plus theta 1 squared sigma squared z. Are we still together?
Yes.
Okay, then from there, because we want to deal with the gamma 0, we want to solve for gamma 0 now. You can take phi 1 squared gamma 0 to the left hand side. Okay. Then when we take it there, we're going to get what? I don't have a space here. Just tell me when you're done. Just want to go to the next page.
We're going to get gamma 0 into 1 minus phi 1
Phi 1
squared.
squared. Yeah.
Yes.
Yeah.
Equals to
Which is
the
equal to
remaining ones.
okay. This is equals that. Gamma.
You're not done, sir.
You're not done. But you can
Yes,
just
sir.
do it on your that is a simple arithmetic. You can just say, oh, you are still copying.
Okay.
Oh, if you're done, then you will tell me you're done, isn't it?
Yeah.
Okay. So you are going to have 1 minus phi 1. That's what we are saying. Gamma 0, which is equal to, on the right you have what?
2 psi 1
phi 1 theta 1.
Theta 1 sigma squared z plus sigma squared z plus phi 1 squared sigma
It's not
squared.
the theta 1. Theta 1 squared, is it?
Yeah, it's
Like
theta
this.
1. Yeah.
Yeah, it's like this. Okay. Then, therefore, your gamma 0 is equal to what? 2 phi 1 theta 1 plus 1 plus theta 1 squared sigma squared z, all divided by what? 1 minus phi 1 squared, isn't it? It's like this, isn't it?
Yes.
Yes.
So now this is equation number 5. Then you can substitute equation 5 from 4, I think so, to get gamma 1. Substitute equation 5 from 4 to get gamma 1. So gamma 1 will be equal to, isn't it? Hey, what is equation 4? Yeah, phi 1 gamma 0. Phi 1. So gamma 0 is the whole of that. So we put 2 phi 1 theta 1 plus 1 plus theta 1 squared. Okay, sigma squared z. Let's forget about sigma squared z.
Sir, you forgot to. Oh, all right.
Yeah, I want to write that one. Plus what? Theta 1.
Theta 1
Okay, it's
S
like
squared.
this. Sigma squared z. Then you divide by here. Here you are dividing by 1 minus by 1, isn't it? So sigma squared z, so it's outside anyway. So now you are going to have what? Phi 1. Or you can just multiply through here. Phi 1, multiply it through. Then you're going to get what? 2 phi 1 squared theta 1. Okay. Plus phi 1 plus phi 1 theta 1 squared. Okay. Plus theta 1 minus Phi 1 squared theta 1, isn't it? Then you divide everything, but here now there is a sigma squared z. Divide everything by 1 minus by 1 squared. Are we still together?
Check
Okay, let's just
application.
explain that part of minus.
Come again?
That part of minus there. On the numerator there is minus phi 1 squared.
Phi
Yeah.
Oh, it's coming from here. Isn't that we're having this one? Then here is over 1. So this one goes how many times this one, then it multiply by this one.
Oh, okay, thanks.
Okay. Then later you see that these ones are the same. This one and this one. So you can subtract 2 phi 1 squared theta 1 minus phi 1 squared theta 1. So you're going to be left with what? Phi 1 squared theta 1 plus. You're still writing? So it's equal to phi 1 squared theta 1 plus, can tell me, plus what? Phi 1 plus phi 1 theta 1 squared, I think, plus theta 1. Yes. I think it's like this, isn't it? Is that true?
Sir.
Yes,
Sir.
sir. Yes, sir. It's like that.
Yeah, I want to say something. Don't move to the next page. I want to say something. I mean, go back to that page.
Yeah.
Yes. Okay, you can move to the next page.
And remember, there is sigma squared z here. And then divide by, is it? There is division. Yeah. Then you divide by what? 1 minus by 1 squared. It's gamma what? It's gamma 1. Are you sure?
It's gamma 1, sir.
Okay. Okay, now gamma 2. So you multiply equation number 1. You multiply equation number 1 by okay, when you are still here, we can do something. This is very complicated, it's too big. Okay, let's do it in this way. From this one and this one, okay, you can find the common factor, isn't it? Which is what? phi 1 theta 1, isn't it? So you can get phi 1 theta 1. Are we together? Open brackets. Then if you take the common factor for phi 1 theta 1, here you are left with what? Phi 1, isn't it? For this one. And there you are left with what? Theta 1. Okay, so this one and this one, you can just group them together as what? Phi 1 plus theta 1, like this. Do you agree? Then 1 minus phi 1 squared, sigma squared z. Do you agree? It's still the same thing, isn't it? Okay,
Yeah.
while you're still there, you can find the common factor again, okay? Which is what? Which is this one. So common factor. Okay, so you're going to have what? Phi 1 plus theta 1. It's a common factor. Then you are left with what? Phi 1 theta 1. Okay, at the back. That side you are left with 1 plus 1. Okay, then sigma squared z. Then you divide it by what? By 1 minus phi 1 squared. We're still together. Oh, you're lost.
Yes, sir. We're fighting.
No, it's fine. So this is what? Gamma 1. Let me just take it to be equation number 6 anyway. So now from equation number 1, you can multiply equation number 1 by xt minus 2, then later you take expectations. What do you get? Equation number 1 multiplying equation number 1 by xt minus 2, then later you take expectations. What are you going to get? Can I move to the next page?
No.
Next page. We are left with 6 minutes. You just want to finish this.
Yes, sir.
You can move, sir. You can move.
Okay, so multiplying equation number 1 by xt minus 2, then you take expectations, you are going to get this expected value of xt minus 2, okay, which is equal to what? Phi 1 multiplying by xt minus 1 multiplying by xt minus 2. Okay, then you said plus expected value of zt xt minus 2. Okay, then plus theta 1 expected value of, let me just write it here, plus this theta 1 expected value of zt minus 1 xt minus 2, isn't it? And you know that this one is gamma what? It's gamma 2.
Gamma 2.
So gamma 2 is equal to what? So what about this one?
Phi 1 gamma 1.
Yes, phi 1 gamma 1. What about this? 0. What about this?
Sigma 0.
0, yes. So we have got gamma 2, which is equal to this one. Okay. So now you can substitute gamma 1 by this, because you have gamma 1, isn't it? So so it's phi 1, gamma 1 is what? Phi 1, theta 1, like that. Oh, phi 1 plus theta 1. Phi 1 plus theta 1, phi 1 theta 1 plus 1. Okay. And remember, we have got this phi 1 here. So there is a phi 1 here. Are we together? Then you divide it by 1 minus phi 1 squared and sigma squared z. Isn't it? So
Can you please
again,
go to the previous? Oh,
back. And again, if you multiply equation number 1 by xt minus 3, then you take expectations. You are going to get gamma 3. Okay, which is equal to the expected value of xt minus 3, sorry, which is equal to what? So we are going to get the phi 1 xt, yeah, phi 1 gamma 2. You are going to get this. So gamma 3 is equal to expected value of xt minus 3, which is equal to phi 1 gamma 2. And we have already calculated gamma 2. So we substitute, you're going to get phi 1 squared. So gamma 3 is equal to phi 1 squared, phi 1 theta 1, phi 1 theta 1 plus 1. Then sigma squared z. So then you divide by what? By 1 minus phi 1 squared. So this is
Sir,
what we're going to, yes.
can you repeat the last step? That last step.
For gamma 3, I'm
Yes.
saying we are multiplying equation number 1 by xt minus 3. Then you take expectations.
Okay.
By so doing, you are going to get phi 1 gamma 2 because the rest are going to be 0. But
Okay.
you have already calculated gamma 2, which is this one up there. Then you substitute gamma 2 by this, then you get this.
Okay.
So this is gamma 3. So remember, we are finding the autocovariance functions. In other words, we're finding gamma 0, gamma 1, gamma 2, up to gamma k. Then let's generalize it. Gamma k now. Gamma k will be equal to what?
Phi 1 gamma k minus 1.
Yes, that's true. Then the rest is going to be the same. What he's saying is that gamma k, we are going like this until you reach gamma k, which is equal to the expected value of xt minus k, which is equal to, you are going to get phi 1 to the power k minus 1, open brackets, phi 1 plus theta 1, phi 1 theta 1 plus 1, sigma squared z. Okay, then you divide by what? 1 minus phi 1 squared. So what do you say? 4 for k equal to what? Can't start from 0, you're going to start from 1, 2, 3, and so on. So gamma k, gamma when k equal to 0, so you're going to get the expression that we just gave you previously. But for k equal to 1, if you substitute 1 here, you're going to get 0, which is 1. You're going to get the whole of this divided by this. Okay. But if you substitute k by 2, you're going to get 1 to the power 1. Then the rest is going to be the same, and so on. So this is autocovariance functions. So remember, we just want to calculate the autocorrelation function. Immediately when after getting autocovariance is then that you can get autocorrelation functions after substituting. So ACF for XT. In other words, it's autocorrelation.
Time.
But it's time up. It's time up.
Okay, let's stop. But anyway, just go and finish this one.
I will finish together, sir.
It's not necessary because you have everything with you there. So what you have to do is to find row 0, row 1, row 2, up to row k, which is simple because you have gamma 0, gamma 1, gamma 2 up to gamma k. And this one, you know that is gamma 1 over gamma 0. This one is gamma 2 over gamma 0. This one is gamma k over gamma 0. So the matter of substituting, you're going to get the correct answer there. Any question?
So, sir.
Morning, sir.
Yes, morning, afternoon already.
Okay, afternoon, sir. So may I please ask you a question? I'm a bit confused on something. Now, whenever you would ask us to calculate covariance, or whenever you do it, autocovariance, you'd always use cov. So now I'm a bit confused now, because now all of a sudden we're using expected. So I don't know if I'm mixing up stuff.
No, you're not mixing. I told you at the beginning, I don't know whether you were there, but let me just remind you again. I said, while we were still doing moving averages, I said we're using moving average processes. And when we calculate the gamma 0, gamma 1 using moving average processes, you have to use, we're going to use curve, let's say of xt and xt. Then later, we are going to use expected value of xt and xt. And I said, these two are the same. We're just differentiating them because we are using auto-regressive. But in the moving average, so they're the same thing. They're the same thing.
So but specifically when we're using ARMA, when we're using the procedure of ARMA, we're supposed to use the one for expected and leave using cov out.
Because, yeah, that's true. For ARMA,
True.
combination use expected value because you're multiplying something by something, then you take expectation. But rather, anyway, it's still the same thing with the cov.
Same procedure.
The same procedure.
Oh, okay. Okay, thank you, sir.
Okay, see you.
See you on Friday, sir. Child so said.
No, you are not going to attend tutorial. Oh, you don't have any question. So there's no need to be there.
Sir.
We're gonna be there,
I'm
sir.
just asking. If you have question, I'm around. If you don't have huh?
Stop recording.
Child so say. I so say no chai.